Good morning, everybody. And today we will be talking about writing equations to represent relationships represented in tables. So this is lesson 7-2. We are on page 405. There you go. You can see it, 405 in your workbook. So we are going to continue talking about independent and dependent variables. Now, remember, we talked about independent variables as being the input, and whatever we do with the input determines the output, or the dependent variables. So let's take a look at our first situation. Luciana earns $8 per hour walking dogs in her neighborhood. The table shows the relationship between the number of hours H she walks and the total amount D in dollars she earns. To write an equation that relates the variables H and D, we first determine the rule that describes the relationship. So what we want to do is look at our input. Our input here is 1, and our output is 8. Now, there's two different ways you can say going from 1 to 8 would be, first would be 1, you could do times 8 equals 8, or you could do plus 7 equals 8. So there's two different ways to get to 8. So let's try it with the next number. Now, if we use 2 and we get 16, 2 plus 7 doesn't equal 16, so we know that that is not an option. Our rule here then would be 1 times 8, 2 times 8, 3 times 8, and 4 times 8 to get our outputs over here. So if we were to then describe the rule, we would say that it would be 8 times the number of hours H. 8H would give us the output. 8 times H would give us our output. So that would be our rule. Now, to confirm this, right, we always have to check our answers. And in order to check our answers, we want to work backwards. So what I'm going to do is I'm going to take my output, which is 8, and divide by the number of hours to find that it really equals 8. Same thing here. Let's do 16 divided by 2. Does that equal 8? Yes. So we know then that our rule is times 8. Turning the page to 406. So we use that rule then, 8H, to write an equation relating the two variables H and D. So we would say the D, the total dollars amount earned, equals 8 times H, or the number of hours worked. So let's take a look at example 1. The table shows the total cost C in dollars for buying T souvenir t-shirts. We're going to write an equation to represent the relationship between C and T. First thing we need to do is identify the variables. Well, our independent variable is going to be T, because that is our input. The dependent variable then would be the number that changes depending on T, which is C. Now we need to take a look at our rule. What are we doing to 1 to get to 9? Now, two different options, right? We could do 1 times 9 to get to 9, or we could say 1 plus 8 equals 9. Now, if I try both of those with the next number, 2 times 9 or 2 plus 8, only one of them would work, and that would be the times 9. So we know our rule would be 9 times the number of t-shirts, so 9t. 9t, right? So 9 times 1, right, which was our number of t-shirts, we would get 9. 9 times 2 would give us 18, so on and so forth. So when we write our equation, we would say our dependent variable, C, equals 9 times our independent variable, T. C equals 9t would be our equation here. C equals 9t. Let's go ahead and try that with our check. The table shows the total cost, C, of belonging to a gym for M months. We write an equation to represent the relationship between C and M. Now, whatever we do here, we want to start with our dependent variable. So is M or C our dependent variable? Remember, dependent is our output. Okay, so we're always going to start with C equals. Now, the next thing we need to do is figure out what are we doing to 1 to get to 24.95. Now, I can do 1 times 24.95 or I can add. Now, it looks to me that this is going to be a multiplication one because we're continuing to get bigger. So we're going to do times 24.95. So we would say 24.95 times the number of months M. Each month times 24.95 would give us the total cost. All right, let's turn the page now to page 408. Sometimes we have more than one step in our equation. So we might multiply and add or divide and subtract or something about that. Now, we're going to figure out what that means. So sometimes the relationship between two variables cannot be accurately described by a one-step equation. In those cases, check to see if more than one operation is involved. We consider the following scenario. An online store sells baseball bats. You will pay for each bat that you order plus a one-time shipping fee. So here's some keywords, plus a one-time shipping fee. That means we're going to add that on one time. The table shows the relationship between the number of bats ordered and the total cost. We're going to write a two-step equation to represent the total cost C in order to ship B baseball bats. So what we need to do is look for a pattern. The output values here, what do we notice about them? As this is increasing by 1, this is increasing by 2. So if this is increasing by 2, that means the input value, the rule would include a 2b, right? So whatever we're doing, we're going to be multiplying by 2. Now, if we do this times 2, right? 1 times 2, well, that would only give me 2. And I need to get to 6. So how can I get to 6 from here? What else are we doing? Well, in this case, we would be adding 4. Let's try this. What if we had 2 here? 2 times 2 is 4, but I still need to get to 8. So that means I need to add 4 more. Now, in both of these, we've both added 4. So we know then that our one-time value, right, our one-time shipping fee would be $4. So the rule would then be 2 times B, the number of bats, plus 4. So if we're writing our equation for that, we're going to start with our dependent variable. The cost equals 2 times B, the number of bats, plus 4, which was our shipping fee. Okay, we're able to check that throughout all of these, and it works. Okay, it all works. So let's go ahead to example 2 on page 409. Now let's take a look once again at our table. The first step is to notice any patterns. So if I'm looking here, this is increasing by 1, this is increasing by 2. Now if this is increasing by 2, remember that means we have to multiply by 2 somewhere in our problem. So let's check this. Now if I put this in and just use the rule 2 times H, 2 times 1, right, the number of hours, that gives me 2, but I need to get to 5. So I would need to then add 3 here. Now let's see if that works in all the rest of the situations. Now if I have 2, 2 times 2 is 4. To get to 7, I would need to then add 3. Oh, it does work. So we know then that our rule would be 2H plus 3. So remember, first step, look for the pattern. What are we increasing by? That's what we're going to end up multiplying. Then we would see what we need to add to complete the problem. So when we write this equation, we say n, our output, always start with your output, equals, what is our rule? 2 times the number of hours plus 3. Let's try our check here. Now, when we look here, once again, we start with what is the pattern? What are we increasing by each time? So when we do this, right, we always start with our output, F. Our output is increasing by 20 cents each time, right? times the number of days. And then we say, well, 1 times 20 cents is only 20 cents, and we need to go 10 cents more. So we would add 10 cents. Let's see if it works here. 2 times 20 cents is 40 cents plus, oh, we have to add 10. Would that equal 50? Yes. So this would be the equation we would write for this situation. All right, final problem here. Each evening, Autumn and Bennett painted signs for a school campaign. The table shows the total number of signs painted after a certain number of hours. If the pattern continues, how many more signs will Autumn have painted than Bennett after painting for 9 hours? So you're going to compare, right, both of these and find it for 9 hours. As always, please make sure to email me your answers so that I know that you've completed this. If you have any questions, please let me know and I will be happy to help. And have a great day, everybody.